Alright. Alright, this is the history of the atom lesson. For this lesson, you're going to want to make sure you fill out your sheet as we go, especially the things in yellow. And definitely also make sure you write any questions you have in the margins. Atoms is a really tough concept to make sure you fully understand, so I'd expect that everyone would have at least some questions written down in the margins that we can discuss when we return. Atoms. Atoms make every single element. Atoms make up every single object that you can see in front of you. So if you're looking at a pencil, for example, and you look at smaller and smaller parts, like the graphite that makes up the pencil, well, that's made of carbon. If you get smaller and smaller, eventually you'll see sheets of carbon that are put together that rub off onto your paper, and finally you'll get down to just single carbon atoms. Again, atoms make up everything that you see in the world around you. Anything that has mass and takes up space. Everything is made of atoms. The idea of atoms was originally come up with by Greek philosophers. They thought if you took something like a rock and you broke it into smaller and smaller pieces, eventually you'd break it into such small a piece that you couldn't break it apart anymore. And that's what they called an atom. And in Greek, actually, atomos means indivisible, meaning you can't break it apart. So the modern scientists, the first modern scientist to really expand on the idea of the atom was John Dalton. He did a number of experiments. He looked at experiments done by past people, and he came up with his idea, which was that atoms were small, round, solid particles, and that atoms can't be destroyed or divided. So you can't make or create a new atom, or you can't divide it doing ordinary chemical or physical means, and that each element was made of different atoms. So if you had a bunch of gold, that was all made of gold atoms. If you had a bunch of iron, that was all made of iron atoms. His idea of the atom as this small, solid, round ball lasted for quite a while. It lasted until another scientist did some other experiments. J.J. Thomson was a scientist that did some other experiments and realized that there was a negatively charged particle that could be transferred from atom to atom. So he took Dalton's model, which would have just been a whole bunch of balls, the atoms next to each other, and realized that inside there must be this negatively charged particle, which he called the electron, which can go from atom to atom. And so he changed the model and came up with what he called the plum pudding model, because plum pudding is a dessert in England. If he was discovering that here in America, he might have called it the blueberry muffin model, with the stuff of makes up the atom being the dough of inside the muffin, and then the little electrons that can get transferred from one atom to another, the blueberry muffins. In plum pudding, it'd actually be little raisins. There were other ideas and other experiments done by other scientists to add our understanding of the model. This was one by a Japanese scientist. This one didn't last too long, but they compared it to the solar system. The next really important idea was done by Ernest Rutherford. And he came up with an experiment where he took gold foil. And gold foil, since ancient times, has been able to be pounded really, really flat. So it's just a couple of atoms thin. And he took that really thin gold foil and he shot a alpha particle at that gold foil. What I'd like you to do is go ahead and think, what would happen? So pause the video for a second and write down what would happen if you shot a smaller, positively charged alpha particle at this wall, very thin wall of gold foil. Take a second to do that now. Okay, what Rutherford found was actually totally unexpected. He found that most of the particles went straight through. Some of the particles bounced almost straight back, and then a few particles went through but were deflected slightly to the side. He took those three findings and realized that Rutherford and Thomson's model of the atom had to be wrong, and he changed the model, and he won the Nobel Prize because of it. What do you think he changed the model to? What does that tell you about the atom? Well, what it tells Rutherford was that the atom had to have, since most of the atoms went straight through, the atom has to be mostly empty space. Since some of the alpha particles hit something and bounced almost straight back, there had to be something very dense and very hard in the center of that atom, and he called that the nucleus. So there had to be a small dense atom at the or small dense part of that atom at the center, which he called the nucleus. And then he realized that since the alpha particles were positively charged and were deflected away from that nucleus, that nucleus must also be positively charged, because he knew that like charges repel and opposite charges attract. So if it was negatively charged nucleus, you might expect that positive and negative charge would stick together, and that's not what happened. So his model of the atom was then the new model that was used, and is still the basics ideas of that are still used today, although people have understood some more things about the atom and added onto it. James Chadwick was the next person. He discovered the last particle inside the atom, the last basic particle, which was the neutron. The neutron is a non-charged particle, so the neutral, and it has almost the exact same mass as the proton. And it is also located in the center of the atom inside the nucleus. Next really famous scientist was Niels Bohr. Bohr discovered and did a lot of work with experiments with electrons. And he discovered some really interesting things about electrons. That electrons don't behave how just normal things that you look at in your everyday world behave. One of the key ideas is that electrons can only exist in very certain spots, and he called those specific orbitals, and they can only have very specific energies. So if you imagine walking around in the classroom, you can walk around and you can stop anywhere you want in the classroom as a human. If you were an electron, though, you can only stop at very specific places, maybe only at one of the rows of desks. So you could only stop exactly at that row. You could not stop halfway between. It's either one place or the other, and that's it. And because of that, you see electrons have very specific energies, and you can do, and you'll learn about this in high school chemistry, about a spectrum of different atoms, which you can use it to help identify different atoms. The current model of the atom is called the quantum model. And the key additions to this, again, have to deal with electrons. And the main one is that you can never know exactly where an electron is located and its speed. So you can't know its location and its velocity at the same time. You can only be certain of its probability. So you can say, hey, there's a really good chance the electron is pretty close to the nucleus, a little less chance that it's farther out, and there's a ring here where there's an even a little bit less chance than some of the farther out spots. It's just not as likely the electron's actually there. So the electrons exist in clouds around the nucleus. And again, they don't behave as normal things that you can see. We'll talk more about that in class. Here's some pictures of what some of the different orbitals look like. You can see the shapes while they start out, just spherical, can get kind of fairly weird pretty quickly. You won't be expected to know this. You'll learn more about it in high school chemistry. Here's some experimental evidence of what the shapes of those orbitals actually look like. Once you start getting into the deeper orbitals, they can get into some really bizarre three-dimensional shapes. This is the current model that you're expected to know. So please go ahead and draw this into your lab notebook and label it. What you've got is, just like Rutherford found, you've got a very small, dense nucleus at the center of the atom. It's made of positively charged particles, which are protons, and no charged particles, or neutrally charged particles, which are neutrons. In a cloud around the nucleus, quite a large distance away from the nucleus, actually, this picture doesn't show it really well, are the electrons, and those are zooming around in the cloud outside the nucleus, and you can't know exactly where they are, only the probability. Scientists are continuing to learn more about the atom, and our model is continuing to prove. we just went over the basics of the model of the atom, but as you continue to learn more about the atom in high school chemistry and college chemistry and beyond, you'll learn that there is quite a lot to know and quite a lot to still learn. This little guy here was actually made by arranging carbon monoxide molecules on a palladium surface, so they made a little sculpture from atoms. So you can see the carbon and the oxygen atoms lined up together to make that little picture. Hope you enjoyed it. Again, make sure you've written down your questions as well. Your answers should be filled out from the sheet for the notes. Thank you.